Hi, I've chosen to present on opportunities and challenges of using offshore wind power to augment electrical energy needs along the coastal areas of the country. My goal is to help raise awareness of the potential of wind power and to discuss some of the issues posed by coastal wind power generation. This is more of a primer than an exhaustive study, so keep in mind that your information mileage may vary based on personal preferences, level of expertise, and technology flavors of choice. Wind versus solar versus geothermal versus bio. Let's start by covering some of the ground rules first. Ground rule number 1. We're talking about turbines and not windmills. A turbine is a rotary mechanical device that extracts energy from a fluid flow and converts it into useful work. Ground rule number 2. When we say offshore, I'm really talking about the industrial strength turbines that sit at the edge of our sight lines from shore. They're about 12 miles out and would be barely visible with the naked eye. Ground rule number 3. We're talking about really big wind turbines. Turbines that stand about 250 feet tall and have a rotor that spans about 104 meters in diameter. The picture that you're seeing would be a depiction of a 747 spinning at the top of the hub of one of these turbines. These things are really big. That's it for the ground rules, so let's take a closer look at the opportunities and the challenges. The opportunities include green energy production, plenty of potential, untapped, lower price per kilowatt hour, and upgrades to our aging power grid. The challenges include financial cost of energy, power consistency, and technical challenges. Offshore wind represents a green renewable energy source. It won't expose us to pollutants and won't cause asthma. It won't cause or produce radioactive waste, and they don't require mountaintop removal, such as they do in coal mining. The potential for wind is enormous. As you see on this map, the darker colors show the best wind resources. The coasts are clearly identified. In fact, the National Renewable Energy Labs project that we have 4 times the generating capacity of the current grid sitting offshore at this moment. Offshore wind can help us drive down the cost of power through innovation. As we get better at deploying larger wind turbines, we'll find that the cost of power can be reduced by as much as 50% over the course of the next 20 years. Offshore wind can help us bring power to where the people are. In fact, the coastal areas of the United States and the area along the Great Lakes alone consist of 80% of the total electrical demand within the U.S. Let's take a look at some of the challenges. The challenges include the high cost of energy, delivery of consistent power, installation in areas that we're not used to performing in, and connecting to the grid. Prices for energy currently from offshore wind come in at about 25 cents per kilowatt hour. These prices are expected to decline to about 10 cents per kilowatt hour by the year 2020 and down to 7 cents per kilowatt hour by the year 2030. These costs are being driven down by better equipment, better site selection, greater expertise, and innovation. Another factor in offshore wind is power consistency. What happens when the wind stops blowing? Unlike land-based systems, ocean-based systems lack obstructions and are provided with a consistent level of wind power. We could also take advantage of the coastal distribution of wind turbines so as to provide sources of wind that can support multiple sites. Installation of offshore wind turbines goes beyond the current technology level, so innovation would be required in order to meet the challenges associated with installation. The last of the noted challenges is the interconnection to the grid. Tying into the grid represents a major technological challenge. Over 350 miles of cable from northern New Jersey to southern Virginia would be required for the Atlantic wind connection. This offsets carbon pollution for approximately 5 coal plants or 3 million cars. The cost of $5 billion is projected, and the completion date is expected to be around 2021 for a 6,000 megawatt power system. It's clear that offshore wind represents the convergence of many opportunities and challenges, but its time is right and action is needed to make it a reality. Offshore wind, its time has come. Thank you for your time and attention.